Hello students, in today's class we will start with the module 4, that is groundwater exploration. So in this module we are going to learn what is mean by groundwater exploration and what are the different methods for groundwater exploration, like seismic method, electric resistivity method. These are the very commonly used methods. Along with this, we are going to also study electrical logging, radioactive logging, the geophysical techniques, induction logging, sonic and fluid logging. So these are the various methods of groundwater exploration. So first, before starting with the methods, let us understand what is mean by groundwater exploration. So groundwater exploration is the investigation of underground formations to understand the hydrological cycle, know the groundwater quality and identify the nature, number and type of aquifers. So we all have studied what is mean by aquifer, where the ample of water is available, that we term as aquifer. So to know whether it is a good aquifer or a bad aquifer, we must know the geological formations present in that area, right? And that formations will tell us the hydrological cycle, that is the study to know the groundwater quality and to identify the nature, number and type of aquifer. These methods are very useful. So a detailed knowledge on groundwater resources enables its sustainable use, where the regional distributions of resources, the hydraulic characteristics of the aquifer, as well as the regional and temporal variations of the water quality, they are the important factors when we deal with the groundwater exploration. So we must have a detailed knowledge, okay, because although the groundwater cannot be seen on the earth's surface, so there are variety of techniques that can provide the information regarding its occurrence under certain conditions. Even the quality of the water will also help us to know what type of formations are present, what quality of water is present, okay. So there are subsurface investigations of groundwater. They are helpful for us to know the subsurface geology or subsurface formations. So there are different groundwater exploration methods. First one is geological method. So geological method, it involves interpretation of the geological data, and even it includes the field studies, wherein you have to go to the field and do the survey and perform the tests, then analysis and hydrological interpretation of existing topographic aerial photographs, geological maps and the different logs and other important records we must know, that is studied under geological methods. So geological studies, these enable us to study the large areas, okay, and that will help us to know the groundwater occurrence, okay. So a geological investigation, it begins with the collection, then analysis and hydrological interpretation of the existing topographic maps. Then we will be having already the topographic maps of the areas. If you study that information also will help us to know the groundwater conditions at the particular area. Even the aerial photographs or satellite images, then geological maps, then different logs and other records, they help us to know the groundwater availability. So this along with this, we must have the geological field reconnaissance survey to be done. Okay, that will help us to understand the stream flow or the springs. Then if we can also perform the well pumping test, we can study the water level conditions in the wells. So that all is included under the geological methods. Then even we must know, we must have the knowledge of the depositional and erosional phenomena or the events happening in that particular area, whether the rocks are weathered rocks or they are which type of rocks are present, the type of rock formation. That also will help us to know the groundwater availability in the particular area. So this all is studied under the ground geological method. Then next is remote sensing method, remote sensing and GIS. So the photographs of the earth which are taken from either aircrafts or satellites at various electromagnetic wavelengths, okay, they can provide us very much useful information regarding the groundwater conditions. So this technology of remote sensing has developed rapidly over a recent years, okay, while its applications to the water resources are still being discovered. Okay, we have to take many investigations. Okay, this is an upcoming branch wherein we can study the groundwater on a larger scale. Okay, and this will be very much helpful. Okay, the remote sensing, that is, we have to study the satellite images or photographs which are taken, okay, from the space. So even the stereoscopic examinations of aerial photographs, they also are very much important. Stereographic is like we see the 3D image, right? 3D movies you might have observed, right, wherein the overlapping of the image is done, and this is observed with the help of stereograph. Stereo We have stereographs like pocket stereoscopes, okay, and we have mirror stereoscope also to observe such type of images. So stereoscopic examination of the aerial photographs, that is also that has also gained importance over a period of time. Okay, and the different features like pattern, color, whatever is then relief, that is the slope, okay, that we can identify, in the image, and that will help us to know the groundwater conditions or surface conditions, like what is the geology in that area, what type of soil moisture. Even we can find out the moisture content in the soil. Okay, then vegetation, then land use, land cover patterns. Okay, that all information you can extract just by observing the satellite image or the satellite images or the aerial photographs. So that is again a very much helpful technology to know about the groundwater. Then next comes is geophysical method or geophysical technique. So geophysical, here we are applying the physics here. Okay, like we are sending the waves, we are sending the current, then we are calculating the velocities and time taken. All that is studied under geophysical method. So geophysical exploration is the scientific measurement of the physical properties of the earth's crust for the investigation of different mineral deposits or the geological structures. And this geophysics in the past few years, that also has reached a place of vital importance, because it is scientifically followed or developed. Okay, so there is a lot of accuracy in the geophysical methods. So geophysical investigations of the buried strata or underground strata that is made from the land surface or in a drilled hole, okay. Drilled hole samples also give us the in detail information regarding what is present below the ground. So such type of logs or the land surface information along with the geophysics, that will help us to know the groundwater conditions or groundwater availability or properties in a well defined way. So these geophysical methods they detect the difference of the physical properties within the earth's crust, like the densities, the geomagnetism, elasticity and electrical resistivity. Okay, so these are the different properties of material which are varying with the material, like different materials have different properties, so that are studied under geophysical investigation. So they are measured, okay, by sending either current or the electric current or even the seismic waves. Okay, so these properties help us in terms of the geological structure, the rock type, the porosity, then the water content and water table, and even the water quality we can find out with the help of geophysical methods. So there are various geophysical methods. There are surface methods, then we have subsurface methods. Okay, so the seismic method, electric resistivity method, which are performed on the surface, so we call it as surface method. Then electric logging, radioactive logging, all these logging methods are there. Those are geophysical methods, that is borehole physical or subsurface physical methods. So now we'll discuss the first method, that is the seismic method. Okay, so seismic method and electrical resistivity method, they are the surface type of geological methods. Okay, and which are very widely used. So first we will deal with the seismic method. So what is meaning of seismic? So these are the waves, okay, seismic waves which are generated during an earthquake. You might have heard, right? So seismic waves or the seismic reflection method that provide information on the about the deep seated strata, that is around 750 meter down. While the seismic reflection, there are two types, seismic refraction and seismic reflection. So here seismic reflection, what it does, seismic reflection method provides up to 750 meter deep information, while the seismic refraction method, it covers only few hundred meters below the ground surface. So because of this reason, the seismic refraction methods are used in groundwater investigation, because we know the water is available up to certain depth, not too deep. Okay, so the seismic refraction methods are commonly used for groundwater studies. So this seismic refraction method involves creation of a small shock, okay, as you can see in the image here, right? So here this is the ground surface and there is a source of energy here, that is the explosion is done at that point. Okay, the seismic refraction method, it involves creation of a small shock. Okay, we create artificially we create a shock here at this point on the earth's surface, either by the impact of heavy instrument or by a small explosive. Okay, and we measure the time required for resulting sound or the shock wave to travel. Okay, time travel to know the distances. Okay, and the seismic waves follow the same law of propagation of light. Okay, or the rays, and they may be reflected or refracted at any interface where the velocity change occurs. So here in this image we can see there are different formations, right? This is unsaturated soil. Okay, this is the water saturated soil wherein water is present, and this is the hard rock or the bedrock. So here the after when you do the explosion, the waves are generated. Okay, some are reflected and some are refracted. So here these are the different detectors, or they are also called as geophones. They are placed at the various locations from at a distance from this source of energy. So the waves are picked up at various points on the ground surface by the geophones. As you can see in the image, they are the geophones are the sensors. Okay, they are the sensors, and they record the time traveled. Okay, so by knowing the arrival time of different waves at different distance, okay, from the energy source, okay, the velocity of propagation of the wave through each rock or the each layer, that can be calculated. So the velocities are characteristics of a particular rock in a particular conditions, that is whether the rocks are jointed or they are saturated with the water or they are weathered. So depending on the type of rock, type of availability of water, the waves, they show change in the velocity, or the time taken by the wave to travel will vary depending on the different formation. So a time travel curve, okay, is plotted. So before going to curve, I'll show you one more image wherein you can see how the test is performed. So here in this image you can see there are drill truck, then shooter which will shoot this is the shoot point wherein the waves are, or there is a shock which is artificially generated, and these are the different rock materials which are present below the ground. So topmost is the weathered rock, then there is a sand, there is a shale, then limestone, sandstone. All these are the different rock formations present below the ground. So whenever there is a generation of shock, the different waves, they travel with different velocities from the different layers, and these are the different geophones which will receive the waves which are reflected or refracted from the from this point to the different locations, or the geophones cables are attached, and these geophones are record the seismic wave travel time. So like this you will get the graphs. Okay, from this graph you can find out the time taken for the wave to travel from the source to the receiving station, that is the geophones. So like this curve you can plot after collecting all the data from the geophones. So the time and the distance, if you plot, you will get the curve. Okay, so these are the different geophones. Then there is a change in the velocity, right? This is the v1 velocity at this point, that is v1, v2, that is the velocity is changing because the curve is changing. Okay, so like this we can find out at various distance the time taken. So the time travel curve, this type of curve is called as time travel curve, is drawn, and by knowing the distance to the first point on the curve, where a change in the slope is indicated, the depth of the rock or the depth of the rock layer, that can be computed from the first equation, that is this one. So depth, you can call it as h, or height, or the depth of the first layer you can calculate by s by 2 v2 minus v1 divided by v2 plus v1. So this will give us the time travel or the thickness of that particular layer where the velocity is changing. So here v1 and v2 are the velocities of the propagation through the earth and the rock layer respectively. Okay, v1 and v2. So using the intercept time, that is t1, the depth h can be calculated by the next equation, that is h is equal to t1, or yes, time traveled, that is t1 divided by 2 into v1 v2 divided by square root of v2 square minus v1 square. This is the equation for the first layer, the second layer. Okay, then that is the first layer. First layer you can calculate either by using this formula or this formula, that will give us the first layer, because the ground is layered. Okay, at different layers we have to use different formula. So this is the first layer, this is the second layer, then all these two are the formulas for, you can either use this formula or this formula for the first layer. Then for the second layer you can calculate, that is h2, the height or the thickness of the second layer, you can calculate as 1 by 2 into bracket time, that is t1 or t2 you can call, okay, minus 2h1, that is the first layer thickness, okay, into square root of v3 square minus v1 square divided by v3 v1, close the bracket, into v2 v3 divided by v square root of, okay, v3 square minus v2 square. So this is the formula for finding the velocities of the seismic waves or the thickness of the strata which is present at that particular area of interest. So like this the formula will continue for different layers. So these are the average velocities of seismic waves for different formations, like for igneous and metamorphic rocks like granite, it is 4580 to 5800 meter per second. For weathered granite it is 305 to 610. For basalt it is 5400 to 6400. For the sediments, that is the sandstone, it is 1800 to 3970 meter per second. So these are the different velocities for different formations. So there are a few advantages and disadvantages of this method. Like advantages we'll discuss first. This can detect both the lateral and depth-wise variation in the physical relevant parameters like seismic velocity. That is one advantage. It will measure both lateral and depth-wise variations. Then this can produce detailed images of structural features present at the subsurface formations. That is, if you come across folded rocks, faulted rocks, joints, that all, even a small variation, suppose there are different minerals present in between, that small variation in the formation also can be detected with the help of seismic waves. Then that can be used to delineate stratigraphic and in some instances depositional features. So by studying these records, seismic records, you can delineate the stratigraphy of that particular area. Stratigraphy is different rock units which are available in the ground. Okay, then how they are formed also you can determine. Then response to seismic wave propagation is dependent on the rock density and a variety of physical, that is elastic constants. So because of this reason, the mechanism for changing these constants like porosity changes, permeability also changes with the different formation. So this can be delineated via the seismic method. So this method will help us to delineate all these properties. Then direct detection of hydrocarbons in some instances is possible. So you can directly detect the hydrocarbons also, like petroleum deposits, mainly offshore also, or below the water, ocean water also we have petroleum deposits. So there also these methods are very commonly used. That is a seismic method wherein underwater this experiment is performed. So these are also used to detect the petroleum deposits. Hydrocarbons is petroleums, that is petroleum and natural gas and oil deposits. So this method is very helpful. Then disadvantages are the amount of data collected in a survey can rapidly become overwhelming. Then data is expensive to acquire because this process involved is costlier. Okay, and the data acquisition are more intense than other geophysical methods. So the data reduction and processing also may become time consuming. This requires sophisticated computer hardwares. Then expert people, we should have, because these graphs will be, that is seismograms, that are the records left on the paper, they are complicated. So you need experts to identify or to extract information from it. Then the equipments which we are using for performing this seismic test, they are in general more expensive than the equipments required for other geophysical methods. Then direct detection of common contaminants present at the levels commonly seen in the hazardous waste spill is not possible. So direct detection is not possible of common contaminants like the spills out of hazardous waste, that is not detected in the seismic method. So these are the advantages and disadvantages of seismic method. Thank you.